System online, accessing classified archives. Welcome to Terminal Unsolved. File initiated. There is a place above South America where Earth's shield folds inward. You cannot see it from the ground. No wall of light appears over the ocean. No siren sounds across Brazil, Argentina, or the South Atlantic. At street level, the planet continues as if nothing is wrong. But several hundred kilometers above the surface, the rules change. Spacecraft enter a region where Earth's magnetic field is weaker than it should be, and charged particles come closer than they do almost anywhere else. The official name is the South Atlantic Anomaly. In mission language, it is a radiation zone. In NASA language, it is a slowly evolving dent in the magnetic field. In operational language, it is a place where machines begin to misbehave. Earth's magnetic field is often described as a protective shield, but that phrase makes it sound solid. It is not solid. It is a changing force generated by motion inside the planet, distorted by tilt, flow, and time. Most of the time, it redirects charged particles and keeps the harshest radiation environment away from low orbit. Over the South Atlantic, that protection dips. The inner radiation belt reaches lower. Satellites crossing the region receive a higher dose. Bits flip, detectors flare. Instruments record noise that did not come from the target they were built to study. NASA does not describe the anomaly as a surface emergency. That boundary matters. People on the ground are not walking through a visible radiation storm. The danger begins higher, in the altitude band where modern civilization has placed its eyes, clocks, relays, weather monitors, and Earth observation systems. This is why the anomaly is more frightening as an operations file than as an apocalypse story. Its evidence lives in telemetry, reboot logs, spacecraft planning tools, and radiation dose calculations. The wound does not need the public to notice it. It only needs one unshielded component to mistake a particle strike for data. From below, the breach is invisible. From orbit, it is scheduled around, shielded against, modeled, and feared. The first horror of the South Atlantic Anomaly is not that the shield is gone. The first horror is more precise. The shield has a weak point. We know where it is, and every day, our machines fly through it. The anomaly announces itself through failures, not spectacle. The International Space Station passes through it. NASA says the station is well protected and the crew is safe inside, but protected does not mean untouched. External instruments on the station must operate in an environment where particle radiation rises. Astronaut Don Pettit described a radiation hotspot in orbit where cosmic ray flux can become 10 to 100 times greater than the rest of the orbital path. In darkness, astronauts can see flashes that are not outside the spacecraft. The flashes appear behind closed eyelids, inside the eye itself, when a charged particle passes through the retina and triggers cells as if light had entered. A dot, a streak, a branching spark. During South Atlantic Anomaly passages, the rate can increase from 1 or 2 flashes every 10 minutes to several per minute. The human body becomes a detector. The eye becomes a sensor. The dark becomes data. The same particles do not stop at biology. Pettit described laptop computers locking up and cameras accumulating damage until images look dusted with electronic snow. In satellite engineering, this belongs to the language of single-event upsets. A charged particle crosses a chip, deposits energy, and a bit changes state. 1-0 becomes 1, or 1 becomes 0, and the spacecraft has to decide whether reality changed or memory lied. This is the file's true texture, not explosion, but corruption, not impact, but interference. Hubble has its own ritual of avoidance. The telescope moves around Earth in low orbit, and the South Atlantic Anomaly intersects that orbit repeatedly. Space Telescope Science Institute documentation describes the SAA as a lower extension of the Van Allen radiation belts. During most SAA passages, astronomical and calibration observations are not possible because of high background in the instruments and guidance sensors. For 7 to 9 orbits in a row each day, Hubble can encounter impacted passages. Observing activities are halted for roughly 20 to 25 minutes during intersections. Those gaps are not narrative drama, they are scheduling geometry. The telescope is healthy, the orbit is hostile for a few minutes, then usable again. The telescope that gave humanity deep fields, nebulae, galaxies, and the age of the universe must periodically stop looking because the local radiation environment becomes too loud. Another NASA instrument, MISR, on the Terra spacecraft, saw the anomaly before it was even meant to see Earth. With its cover closed, radiation effects appeared in the cameras. A blind instrument recorded the shape of an invisible wound. The source is not in space, it is beneath us. Earth's magnetic field is generated mostly by the geodynamo, a moving ocean of molten, iron-rich material in the outer core, roughly 3,000 kilometers below the surface. That motion creates electric currents. The currents create magnetic fields. But the field is not a clean bar magnet. It is a superposition of many sources, tilted, drifting, and constantly revised by the planet's interior. NASA links the South Atlantic Anomaly to the tilt of Earth's magnetic axis and the flow of molten metals in the outer core. ESA's SWARM satellites have made the story sharper. Since 2014, SWARM has measured Earth's magnetic field with enough precision to watch the anomaly change. The latest public SWARM results show that the weak region over the South Atlantic expanded between 2014 and 2025 by an area nearly half the size of continental Europe. The technical paper behind the result gives the colder numbers. The region below 26,000 nanoteslas expanded by 0.9% of Earth's surface area, and the minimum intensity fell from 22,430 nanoteslas to 22,094. NOAA's late 2025 geomagnetic field report keeps the same operational picture. The South Atlantic Anomaly spans the southern Atlantic in South America. The field there is about 1/3 of the strength near the magnetic poles, and the anomaly is deepening and moving westward. This is not one smooth bruise. ESA reports that the South Atlantic Anomaly is not a single block. A region southwest of Africa has weakened faster since 2020. A second center has developed. The valley is splitting. The explanation points even deeper, towards strange reverse flux patches near the boundary between Earth's liquid outer core and the rocky mantle. Normally, in the southern hemisphere, magnetic field lines are expected to come out of the core. Beneath the anomaly, some appear to go back in. That reversal helps carve the weak place above. This does not prove an imminent pole reversal. ESA is careful. At surface level, the anomaly presents no cause for alarm. But careful language is not comforting language. Normal does not mean static. A normal volcano can still be monitored. A normal storm can still close an airport. A normal change in the core can still alter the risk profile of every satellite that crosses it. It means the file is real, slow, measured, and unfinished. The planet's shield is not breaking like glass. It is changing like weather inside metal, far below every city that depends on it. The unresolved part is not whether the South Atlantic Anomaly exists. It exists. The unresolved part is what it becomes, while civilization keeps moving more of itself into orbit. Low Earth orbit is no longer empty. It is crowded with navigation support, climate observation, imaging constellations, communications networks, science missions, military sensors, and commercial satellites built to operate for years while crossing the same hazardous region again and again. Every forecast model, every emergency map, every ship position, every precision time signal depends on a chain of machines that assume the space around Earth is harsh but manageable. Engineers design around the anomaly. They harden electronics. They add shielding. They build safe modes. They model latch-up events and single-event upsets. They use magnetic field maps that must be updated because the field does not stay still. NOAA's recent geomagnetic field reporting describes the SAA as deepening and moving westward. At 500 kilometers altitude, the weak point is not an abstraction. It is an operational coordinate. The more the orbital economy expands, the more often the invisible geometry matters. A particle hitting one memory cell is a glitch. A storm hitting a fleet is a pattern. A map that drifts faster than expected becomes a planning problem. Older spacecraft can lose margin. New constellations can multiply exposure. Future missions may cross a region with a different shape than the one their designers inherited. The South Atlantic Anomaly is frightening because it is not theatrical. It does not need to announce itself. It waits inside normal operations, inside flight plans, inside instrument schedules, inside the error logs of machines that were supposed to be above the weather. It is a reminder that the shield around Earth is not a wall. It is a living field produced by a planet whose interior we still cannot directly observe. We stand on the crust and call it stable. Beneath that crust, molten metal rewrites the sky. Above that sky, satellites cross the weak place and count the hits. The anomaly is slow enough to ignore, and persistent enough to matter. That is its threat profile. No conspiracy is required, no apocalypse is required. The verified facts are already enough. A hole that is not a hole, a shield that is not solid, a planet protecting us with a system that is moving while we are still inside it. File status: unresolved. To maintain clearance for future decrypted files, initialize the subscribe protocol. End of file. System entering standby mode.